before we begin, I want to thank all the organizers, the people from the ECE External Relations team, Amanda Stein right over there, Carrie Hilmer, and Jasmine Cooper helped us out, as well as all the ECEGSA board members who have set up this event and wrote in all the panelists. I'm very thankful for your enthusiasm and your will to share all the information to the students. So to all those who are here, I mean, if you have physical resumes that you want to hand out, you can just leave back over there behind the camera. And a quick note, as I mentioned, this is being recorded, so in case you miss any critical information, you can just go back and have a look at it. Briefly, the panel is broken into two pieces. The first one is about the transition from grad school to industry, about how exactly you settle in once you put your foot in the industry, how it's different from grad school, and all the transitioning things that go along with it. And the second half is more about the application and recruitment process, how exactly you go about the interview process and how to hunt a job, and the other requisite things regarding that. We have a diverse group of panelists, people from startups, research labs, and large companies as well, and those that require citizenship as well. So we do have a diverse panel specifically picked out so that you get as much broad information as possible and get a taste of all the various possibilities available in the industry. The moderator for the first panel is Dr. Blankenship, and he is a professor and associate chair for external affairs in our department. And now I'll ask Professor Blankenship to start with the panel.
All right, well, welcome to everyone, especially the panelists, here and Fred. I am Gil Blankenship, Professor of Electrical Engineering. I've been here for a very long time, and it's a good event. So why don't we introduce ourselves? All
right. Hello, my name is Kratzmeier. I did my bachelor's and master's degree here at Maryland, graduated last May. I see some familiar faces in the audience. Right now I'm working at Northrop Grumman, which is a large defense and aerospace contractor, and I'm currently in a rotational program and get to hop around to a bunch of different jobs, including RF design.
So I'm Conrad Grant. I'm the head of Air and Missile Defense at the Johns Hopkins University Applied Physics Laboratory. I graduated here at the University of Maryland with a degree in physics back in 1978, and then got a master's in computer science and a master's in physics at Hopkins. So I'll be talking about from the Research Institute type of organization. I'll talk about this.
My name is Haroon Ajaz. I did my master's from Junyi Tech, and I work for AT&T. I work for the wireless side of AT&T, and I'm responsible for the Washington-Baltimore market for all the design work and all the new technologies that go over there on our system, and also managing the projects. In terms of a large company, the questions about that.
Welcome, Kosanovic, with Texas Instruments here in Germantown. I'm managing a team of software engineers and embedded software. I got my PhD from Pitt in '95, and then I came here in the area since doing work at PI.
Gerry, McKenna, AT&T. Of course, AT&T always has to be big, so we got two people here. I support an organization that designs cybersecurity services for the federal government. I work here, actually locally in Columbia. And I actually have a degree in computer science, master's in computer science from Penn State, actually 30 years ago this month.
Hi, I'm Akturk. I work for a small company called Electronics, which is a spin-off from this department. I also graduated from this department in 2006, and it's a relatively small company compared to AT&T. It's a giant, I guess. But we do lots of contract work, research and development, which is very similar to the grad work you're doing. I'm Zaki. I graduated from this department last year, and I joined IGI Technologies, which is a startup here in the Technology Advancement Program, where we work on medical image processing. And my role there is I'm a second engineer there, so we kind of do all kind of work in terms of development and business plan, and really talking about how it's to be working in a startup.
Okay, great. So we have a kind of agenda here, so we'll just take a look at the agenda. So the first part of the session is on general perspectives on industrial careers. So most of the students have not worked in industry. And first we just take them as they come. What kind of work would recent graduates or new graduates at the MS and PhD level, what can they expect? You want to start with that one since you are doing it?
Sure. So I had 9 months in my current job, so I had a pretty good feel of what a new master's student graduate. They typically pair you up with an advisory engineer, someone who's been there a lot longer than you and knows the ropes, because as you are coming out of school, yes, you're smart, but you don't know everything about the company and how things work. And as an advisory engineer, you kind of mentor the person beneath you, and you get to do some design work, but it's very oversight with the advisory engineer.
So, excuse me, at the Applied Physics Lab, it's a little bit different. We're not industry, but we are a contractor to the government. People come in, it's pretty much a self-start organization. We have mentoring programs to help the new staff. We also have rotation programs when you come in so that you get experience in a number of different areas. But you can choose to come right in directly into a specific group of work that we do. The work is everything from design of radars to missile technologies to laser technologies to communications, not quite the same as PT&T, but more of the military types of communications, satellite communications, those types of things. We expect people to hit the ground running. And so you come in, it's a team environment, we team you up with others, multidisciplinary, so if your strength is in, say, EE or computer science, we'll team you up with physicists, with mathematicians, on whatever the project is, with a whole varied set of experience levels of engineers that are doing that work. And it's just off and running.
Yeah, so AT&T is very large and focus more on the business area that I am in, which is wireless. For PhD students, I think there are a lot of other like AT&T labs and other areas where you can actually continue and do research type of work. In wireless, mostly we have 2 different programs. One is a leadership program, which we sometimes, I believe I came in last year and was able to hire one person last year. So that leadership program is a program, which is a rotation program, and we try to get the students to come, graduate to come in and work in a couple of different areas of wireless design or optimization and planning, so that they can get a little bit well-rounded. And we also provide them some additional help in getting onto the leadership role as quickly as possible. Other than that, if you come in, like you were saying, we expect them to hit the ground running, and we try to sort of work with them to see what areas that they're interested in. In RF engineering, which is primarily what we do in wireless, we have optimization teams, we have design teams, we have planning teams, we do type testing. So there's a lot of different areas, and eventually you will want to settle down in one area, but there is a lot of opportunities to go into different areas of RF engineering and see what's really good.
Yeah, in Texas Instruments, like similar with other companies, so we are a relatively big company, and we do both now on the digital silicon and hardware and software. So depending what is your background, if you are doing in school similar things, you'll probably just proceed to do something similar in Texas Instruments. We have different tracks for people who come in. We also have rotation programs. We have ability to kind of do some kind of advanced designs in silicon. So if you're kind of engineer who is mostly interested in microelectronics and those kind of things, we have lots of things that we can then keep doing the same way as you're doing research here. If you are more interested in software, we have also a big chunk of work that is focused on real-time signal processing, high-performance computing. So if you're doing that, for example, you can get smooth transition and can keep going. Longer term, you have either to do tech kind of ladder career, you can excel there, or you can at some point switch into management or business. So we're very open for people moving between the roles as they grow in their career. So you may start doing something and then 5 years, 10 years down the road, you may end up doing some business or marketing, if you like, or product management. But probably for PhDs, I don't know, I haven't seen many PhDs going into that role, but You never know.
So what can I add that's different with these folks just said? What I'd say is this, is that, I mean, I've been at AT&T for quite some time and seen how the place evolved. I mean, once upon a time, a company like AT&T hired talent, and it wasn't necessarily interested in applying the talent on any specific project. The idea was there's so much stuff to do, let's bring bright people in, and eventually those bright people will get to work on things that they need to do. That was in a different era of this company. This company now, and I think one thing that's probably vital to do is understand who you're working for and kind of understand what their objectives are. AT&T, at least in my portion of the business, everything is very project focused, everything is very contract focused. I guess in academia, you worry about grants, and you worry about, hey, you got grant money coming in, and grants are out there to perform certain functions. In our portion of the business, it's all about contracts. What contract do you get? What are the needs of the contract? What work you have to get done? So when you're out there and you're interviewing with companies, kind of understand, how you come in. You're coming in as a resource that can kind of work on various different things, or you come in and work in a contract. If you're coming to work in a contract, you will be given a specific assignment with a specific role, specific function, with specific dates, deliverables, and all the rest. As master's or PhD students, the expectation is that you will be contributing pretty much pretty early. You're not going to go in there by yourself, and that's not the expectation. You'll be assigned mentors and such to help you through and understand what needs to get done. But so, like I said, and companies change. So depending upon which company you join, and you might find that if you stay with a company, although I think these days you typically find people just, they change careers and they change companies a lot. But if you stay with a company for a while, even what I just described can change. So, when you're out there interviewing and talking to folks right now, kind of understand, how does the company work? What's the expectation in terms of you coming in? Are you assigned to a specific role, contract, project, or are they kind of bringing you in as a talent pool to work on a diverse set of things?
So at Kuhlman, we operate very differently because we are a very small company. So you have to adapt very quickly. You need to be like the boss. Resistance is kind of futile. And we generally like to have interns, so that becomes your warm-up period, so that when you start working, you should already know what you're going to do. So there's no advice. There's some advising, but it's minimal compared to probably to AT&T. So we generally like to work with people we worked before. I think that's true for most people. And when you start working on a project, you should expect that it's going to change between here to something else, and it may be very different from what you start. And we have a bunch of four main trust areas like software, hardware, sensors, and commercial gadgets, I guess. The hardware and software is R&D. They're very similar to what you guys are already doing. Technique used to work on the universal side of one of our R&D projects, and to make some infrared sensors. We do infrared sensors, ultraviolet sensors, and long-range infrared sensors, and short-wave infrared sensors. And so that is very much like what you guys do every day. You need to make unit go to clean room, you need to make it unit simulated. But in terms of that's the R&D side, in terms of the commercial side, we make small gadgets like wearable electronics. One of the things we did was some kind of a UV sensor. You can put it on your arm, so if you go to the beach, it will tell you when you need to put the sunscreen on, things like that. So that is very different. So we're not concentrated on one area. It may look like scattered, but we have lots of areas to work in. So you need to fit into one of those areas at the beginning. We cannot afford to have someone who would help in general. So you have to start with something that's already going on with the expectation that it's going to change in a year.
So at IGI Technologies, and I guess we are the smallest in all the companies presented here because we are just 2 employees. So me as the second employee, I'm not the founder, but I'm the second employee, you expect to be like a joker employee where you can keep rotating in a given week between very different parts of the product development and the business plan. So while being there for almost like a year and a half right now, I rotated from doing testing to working with the core, with doing business plan development. So for one time we had to prepare 4-minute presentation for NVIDIA Emerging Company Summit. So we spent like a week on doing that. So that's not something you will be doing as a graduate student, but like a new perspective on what you will be doing. So of course, like you will have some mentoring, but also you are expected as a PhD holder or like master graduate degree holder to be doing exploration by yourself. And also, like, we are working on medical image processing. My background was mostly in computer engineering, the implementation of the algorithm. But you still, like, you are expected to grab all these new ideas, like, pretty easily and start working once you are there. So, as I told here, like, everyone will focus eventually on area. Like, in startups and small startups or like beginner startups, you don't have an area. You're rotating from different parts, and that's why kind of more excitement gets, because like you are learning different things at the same time. So how is that different from graduate school? We can like talk a little bit more than like mainly you are now focused on the product development, just like not talking, getting the paper and saying you are innovative. You need some innovation, but you are sure that your product has a market potential, and that kind of makes you think a little bit different than what you will be doing during research paper and so on.
How would you characterize the pressure on your new hires? So, for example, if one takes an academic career path and becomes an assistant professor, there's a certain amount of pressure. You must publish, you must raise money, you've got a 6-year window to get tenure, and after that you can relax, you don't have to do anything. Right on the horizon. So it's a very substantial amount of pressure on young faculty members, and it continues actually. The more successful you are, the more you're expected to do, raise money, become a fellow of a society, and so on. There's a clear path of pressure. How would you characterize that in your own business? So maybe you're not quite there yet, but someone else that could take that?
Well, in research, for research it's a little bit different, as you mentioned. By the way, we do grants, but we're also under contract with the government, so we have products and contracts, same thing. For the first couple of years, there's not a huge amount of pressure. I mean, we talk about people hitting the ground running, but you're sort of tuned in a team. You have support. You're a part of that team. The pressure is mainly borne by your supervisors who have the responsibilities for the delivery of the product. But that doesn't mean that it comes without expectations. First couple of years of your career, any place, I don't think it matters where you go, is when you sort of prove yourself, when you establish yourself. And so you get a chance to start showing your talents and your capabilities. The nice thing about the laboratory is that it is an academic institution. We have about 5,000 people there, so there's a lot of latitude in different types of work that you can do. So if what you come into in a rotation isn't what really gets you up in the morning, you have a chance to do something else. But we also, just like any contractor, have deliverables, have schedules, have to meet costs. All of those things are very important to what we do. So it's not playing around. It's really is serious about delivering a product, in our case, to the government.
Yeah, in the wireless side, we do give at least 90 days to about 6 months for the new hires to come and get technical implemented to do what we do. The expectation is that they use those first few months to really understand what's going on, what's the business. And in wireless, things evolve so fast that we might be doing GSM 1 year, the next year you have GS, and then LTE. So there's constantly you are training yourself for what's coming and what the requirements are, what the technologies are about. The best part about AT&T is we have a load of training available for us, for everyone. We have what's called AT&T University. It offers lots of very, very in-depth technology-related web-based courses. We have trainers that come in all the time. But after 6 months or so, we are expected to be actually taking lead on projects and working on projects, delivering on time. We expect them to show presentations on what the project is about. And one thing that we all try to do with all the engineers is be a little bit more conscious on what and how is the best way to spend the money. So we want them to be financially responsible too, because that's one of the hardest part I have seen. Engineers like to have these big, huge plans, but they don't really care about how much it's going to cost. So we do want them to eventually understand the cost and come up with the best solutions and also manage those costs throughout the process.
Yeah, I can say for Texas Instruments, how that field all that maybe similar everywhere. Pressure really depends on you primarily and on your supervisor, right, to some extent. Right? So most of the supervisors would be reasonable, right, and wouldn't probably put too much pressure on you, but pressure is just your perception because you're new, you're coming in, you don't know what to expect. But if you're confident that you can do certain things, you're in school and you did your work there pretty good, and you came to a company where your skills are needed, you should try to relax, don't panic, and just try to do the best you can, and try to balance the work and life. Don't try to burn out immediately the first few months just to impress somebody. So try to go slowly, ask a lot of questions, try to understand what is exactly expected of you, and then you start getting in and growing into the company, right? And down the road, it will be pretty much the same. You shouldn't panic at any point in time. You should always think about what exactly you need to do, try to understand what the role is that you're in and what you need to do. And try to learn, keep learning. So the fact that you came out of school doesn't mean you kind of stop learning. You'll be learning, obviously, how companies do certain things, but you have to stay in touch with technology and kind of read probably papers and other things, and books, so that you can always be on top of what's being done. And I mean, all people who work for me, for example, I say, you're doing it for yourself primarily. You're not doing it just for the company. You want to kind of make sure that you will be better, and that will be value for the company. And God forbid, if there is a reduction in force, well, I mean, you will be marketable, right? So you can say, okay, I did all these cool things, and I kind of learned a lot, and then people will, want to hire you.
So pressure. I can talk about what I see in terms of how we run our business today. I can also think back 30 years ago when I walked into the company. I think I'd probably agree. You're not going to be under immediate pressure. I think one of the reasons why, maybe with NTT, if you were to contrast what Dr. Blankenship said, is that when you're in academia, you've understood academia. You've been in school for how many years now? You probably understand how school works by now. You probably figured out how to deal with your professors and how to take tests and how to do projects. You've got good at that. That's the reason you're here. If you're going to go into a company, I don't care what company you walk into, and it's going to be a little different. It's going to have a different culture, and everything that comes up later on. I mean, so while in academia, maybe the pressure is going to hit you immediately because there's going to be an understanding. You kind of know all the other stuff that you need to know, so that you then should be able to progress rather quickly through some of these things. When you come to a company like AT&T, for sure, there's a recognition you don't know all. You know you're very good at the skills that you've been trained in, but you probably know very little about the company and its culture. You probably know very little about the customers that we're serving and what their needs and what their missions are. You probably know very little about how we make money. Because ultimately, it's all going to come down to, I don't care who's sitting around this table, ultimately it's going to come down to something's going to be driven by how money is made. And those are the things that while you're going to be very, very good in all the things that you learned in school, and all the technical disciplines and such that you've excelled in, getting to know the company, getting to know the customer, getting to know how the company makes money, those are the things that are going to take you time to acquire. And quite honestly, they will take a career to acquire. So in terms of pressure, I think the expectation is, at least at AT&T, the expectation is, look, you're expected to do well in the things that you know. And for the things that you don't know, you're going to get some slack because, but there's going to be an expectation levied on you that you are going to do more than just the things that you know how to do, the technical things, that you're going to invest some time and effort getting to understand the company and its business and the customers. And frankly, that'll be information that you'll be able to take even if you end up going in other companies, because quite honestly, you'll be able to use that and walk in somewhere else and say, hey, this is the way we did it in this company, or maybe it's slightly different, but at least you have a point to compare it against. So anyway, to answer the pressure question, you're not going to be under immediate pressure. You'll be expected to do well in what you know, and for the things that you don't know,
They'll be given time, but the expectation is that you'll invest in energy and effort in terms of finding out those things as well.
So I think the answer depends on if you're an employee or an employer. So if you're a startup and on the company, if you're an employer, the pressure is like, I think 100 times more than being in academia. Because I do the same things. On average, probably I write 4 or 5 proposals per year, and then apply to different places. In addition to that, we also try to campaigns like Kickstarter campaign, so commercial things. So there are different types of stress, but there's always stress. So contrary to my colleague said, I would say do not relax. So even if you're an employee, I don't think the pressure is as much. But if it's a small company and if you don't perform, nobody can afford you. So you need to at least do what you're expected to do, and even some more, because there are other people who can do similar things. And if you're an employer, then you need to do your technical stuff, then you need to write proposals, which are very time consuming. Then you need to make the budgets for them, which is equal time consuming. Then it needs to be, there are lots of problems. For example, even if you make a budget, you think it's the greatest, then some random accounting place will count on that. So you didn't do this right, this is the percentage you need to support this or whatever, and prove that it is the right percentage. And there are lots of little things that add up. And if you're an employee, you need to think of all those things, and especially if you have people working for you, then you need to make sure that there's money for them. Because you cannot fire people whenever you don't. I mean, you need to make sure there's enough money for a person. So, there are people too, so you're responsible to them. So I think the pressure, if you're an employee, the pressure is a lot more. But if you're an employee, it's slightly better.
So for small startup, usually if you are the first few employees, most probably you are going to work with people you know already. So you're not just meeting because you need to trust the people you're working with. So for me, I started working with my postdoc during my PhD, so I already didn't have the pressure of meeting somebody new or trying to prove myself, because we would be working together for 5 years, and that's why he likes me, that's why he wants me to keep working with him. So we didn't have that, it's basically, but it comes out from a startup like us, where you are funded by small business grant from the government, and it's 1 or 2 years depending on what the grant is. So basically your pressure would be you have to get the cash flow positive or find other way of getting money before you run out of grants. So it's not your paper deadline as you did in graduate school. Now it's going to be defining your product, know what are your customers, and know what the product is going to give you money eventually. So that's what the pressure will basically come from. And in terms of work, it's kind of, we had almost the same concept of we had in our lab when I was in graduate school. It's just basically you get the work done, and sometimes you finish it easily, sometimes it takes longer. But just basically if you want to finish something, you just work on it till you get it done on time. So that's kind of a bit different from what they talk about, because you are still, we don't have every established cash flow, making sales, but we are working in different business where you want to see what kind of product development, what should be your hitting product, and which area should you go after, and which one should you say oh, there's not that much coming from here, so you should focus on that part, not that part.
Anything next, or should you now feeling the pressure?
Yeah. So while they're all been at their companies many, many years, I've only been there 9 months, so it's a good feel on the block. There's a lot of pressure on you, but most of it comes from yourself. You come out of school thinking you know everything, and then you get there and you realize you don't know anything. And it's all up to you to, after the advising engineers, you just can't teach everything in 4 years of 5 years of school. And it's all up to you to figure out what's going on, learn everything, be brought up to speed very quickly, which if you've done a PhD or master's program, the employer knows you have the ability to learn new things quickly, and they expect that. And then once you know what you're doing, you get thrown into a project that, for me, it was redesign this chip, you have X amount of weeks, and oh, by the way, there's a multi-million-dollar program that's on hold right now because this chip doesn't work. So in order to make us millions of dollars, you need to get your act together and design this chip and redesign it. So, and that all came from me doing a good job, being brought to the very quickly and showing that I knew I could take on more responsibility. And the people higher up will notice when you can take on more responsibility, and trust me, they will just give it to you. So if you do a good job, you'll slowly get more and more pressure in. You'll end up as a department head or whatever. Have many, many people, give you depending on you.
Good response. So right now, a graduate student, their job is to do something innovative, something new, especially in a PhD program, and something creative. It has to be new to be publishable. It should be creative to get the respect of the faculty members. And you have a few years to do this, between 2 and 5 years typically in a PhD program. And then this job is often not, the work they do is often not particularly relevant to the jobs that they take. How do you judge them based on their PhD research? So let me add to that. What's the difference between master's and PhD in your eyes? Why would you hire a PhD rather than a master's? And how do you take advantage of the fact that the PhD students know how to do research, at least in one case, one research group?
Sure. So we hire about 100 to 150 new grads per year. The mix is roughly about 30% bachelor's, about maybe 40 to 50% master's level, and then the rest of PhDs. Our work balance, we have a breadth of work. So much of our work is what's referred to as research and development. But ahead of that comes what we call science and technology. And we have about 25% of what we do is in basic science and technology research. Very, very sophisticated technologies, applications that some of which we don't even know yet what they're for. So that's the front end work. Much of that is highly classified work. Then we move into the research and development part, and then we get into product development and fielding and things like that, test and evaluation. For us, much of what we do is this hands-on work. So we have a lot of laboratories. I have over 40 different laboratories, facilities, major facilities that people do their work in just for my department alone. And so, extensive facilities, a lot of hands-on. At any point in time, I probably, out of 1,000 people I've got working for me, there's 200 people someplace around the country doing testing in different, major laboratories or other facilities around the country as well. So much of it is hands-on work. That's where the master's level comes in. We look at the folks who have just gotten their master's as being very proficient at hands-on work. We need PhDs for high-level, that early science and technology research types of work that we do, as well as for specific applications in the programs and projects that we do. So we see that the PhDs coming in and continuing in a research field. Also, we see them as being leaders of technology development. You guys know how to do the research. You have a little bit more experience. You've been in teams, hopefully, in whatever laboratories you worked in. We want you to bring that to us and then help us roll that into the new technologies that we're developing. So, but a lot of hands-on with master's level. Now, for the undergraduates that we hire, that other 30% that we hire, we pretty much expect you to go get a graduate degree. So, I mean, it's and at Hopkins, obviously, we have our own means of getting you through that as well. But many of the people who work for us come back down to Maryland. In fact, the largest number, the school that provides the largest number of undergraduates to us yearly is Maryland, as well as graduate.
So as far as PhD is concerned, I think within AT&T there is the labs that does hire a lot of people, and they continue to do research work. We also have product development. A lot of new products are developed under our headquarters teams, and then we have chief technology officers. So they are not within the office and the team that I work in. I don't believe we have any PhDs in our office. But there are opportunities outside of the RF design area where product development and research labs and other areas that the technology office works on to look at what the future specs for what the future technologies or new enhancements that we are looking to get our vendors to produce are. On the wireless side, we don't produce we don't actually manufacture any of the equipment. It is all done through our vendors. So we work with our vendors and come up with what the new features are that we are looking for. So there are a lot of people who work in that area. Unfortunately, they don't really work in our department. Most of the engineers we have in our department are master's students. And like you were saying, if they have undergraduate degrees, a lot of them, if they're looking to actually get to a manager position or are either looking to do an MBA or get a master's degree.
In text instruments, we have QB labs where we do research, right? And so we pretty much hire PhDs there, some masters. And that's pretty much research into microelectronics and some other areas like performance computing, technology, embedded systems. And then since we don't have too many PhDs, right, we are very picky about it, right? And then in what sense? It's not about just your GPA or whatever actual area of research you did. We would really like to see some kind of wider interest in the candidate, right? So people who, let's say they took EE and they did PhD in microelectronics would like to see some curriculum in physics, obviously, some curriculum in math, probably taking some stuff at the math department. If you're going to work on the chips, like digital design for CPUs, we would like to see some software exposure so you can understand more than just one single area. So because we cannot afford to hire too many PhDs, so we would like to find those who can do a little bit more. So that's maybe one unique thing about TI. So we look at much broader things. You will publish probably if you're in QB labs, if you go to development, because you also have some small number of PhDs in development. You may not have time to publish as much, but you will be encouraged a lot to do patents, right? So, and to innovate in that sense. And that's, to some extent, is actually much harder than writing the paper. As we all know, I mean, like, actually in the last, I don't know, 20, 30 years, there's so many papers that can written without really having much of a value. But because it's kind of pressuring academia to publish, right? So if you look back, the typography of only maybe two papers of books, right? But now,
6 papers.
yeah, 6 or whatever, right? So nowadays people write hundreds of papers, right? So in TI, you will not be encouraged to write hundreds of papers, but you'll be encouraged to think about what can be applied and how to be applied, and you will need to use your PhD knowledge and expertise to these new things that you can copy from intelligence in a sense.
I don't know if I can add much. I think the part of the company that I worked in over the years, most of the candidates, very few PhDs, primarily masters. Most of the work that was done was really applied. It was developing products, developing services. With that said, actually, still on my team right now, I have a number of PhDs. Physicists for some reason, not exactly sure why. And in fact, some of the work we end up doing, again, I mentioned the cybersecurity stuff, some of the stuff is analysis. Of course, a very interesting field these days with all the hacking that's going on right now. And being in a telecommunications company, trying to look at data and figure out what's going on in terms of hacking. And actually, physicists seem to be very good at this, by the way. So in that regard, why is that relevant? Because when it comes to a PhD or a master's or anybody else, oftentimes it comes down to people's ability to look at a problem and look at a problem in depth. And while you might have done your thesis or any particular field, I mean, you might be able to make a career out of that, but more likely than not, you're going to find out that you're probably over time going to have to morph some of the skills and abilities that you have from one domain and perhaps take that to a slightly different domain. Whether you start off in telecommunications and move to medical or whatever the heck the thing is. So I think from a PhD candidate, you're looking for depth of knowledge. You're looking for the ability to look at problems, to derive conclusions, to make, observations in ways that are just deeper than you would get out of some of your other students. And to reinforce, I don't care what candidate you are, you're looking at the ability for candidates to be diverse, to move around, if you choose to reinvent yourself. I mean, in companies like AT&T, we've been around a long time. And even right now, in AT&T, just figuring out we want to start doing everything in software. Actually, we want to move away from all those chips, by the way. We want to actually start doing everything with general purpose processors because they've gotten so damn fast. I mean, before you had to do stuff inside FPGAs. That now you get a general purpose computer and some software, and that's good enough. So, so what do you need those double E's for? Well, you need double. So while you've got skills that are relevant today, 5-10 years from now, your ability to maintain an employee, to make those good salaries and support your family and do all the things you want to do outside of work, you might find that you might have to apply those skills in a slightly different domain. So being able to reinvent yourself along the way is another skill, certainly. I don't care what candidate you are, PhD, master's, or whatever. We're certainly going to look for candidates that have the ability and the willingness and the aptitude to, if they choose. Again, you can always choose to stay where you want to. You can always choose to move to different companies. You can always choose to do that. But ultimately, the market and the economy is going to set some of those parameters for you. So from an AT&T perspective, we'll look for people who we think have the ability with that.
So I agree with what has been said so far. There's not much to add to it. But I agree with my colleague that we need to be flexible at the end of the day. And as we look at half of our employee targets are PhDs because the founders are PhDs, not specifically hired PhDs. But in general, as said before, for the hands-on experience, you look for either bachelor's degree or an MS degree, because you don't need a PhD to make that like the PCB board or solder it. So for those things, the PhD would be an overkill. If you want to give a PhD a salary commensurate with their degree, then it's certainly an overkill. But for very specific R&D contracts, like if it's like a cutting edge, or for example, we just got a contract to make some sort of short-day infrared detector. So you need to go to the clean room, you need to simulate it, you need to make it. And not many MS or BS people know what germane is or how to process it, for example. So for those applications, you do need a PhD, and I would prefer to hire a PhD if I'm not budget for it. But for all the other commercial things, probably I'll hire a PS or MS degree person.
So, of course, I won't add too much, but I'll go back to the main question that to say, like, how do you know what a PhD or somebody who has got a degree come, and how do you know what you want from him? And I didn't hire somebody inside I technologies, but our CEO is a research director at Children's Hospital, and he was looking for postdoc that has some commercial knowledge, and we want to hire a postdoc in order to get him somebody to spend other companies if possible. And that's when I saw when they evaluate PhD, and basically I kind of like that more was what they have. They just talked about their research instead of going to an interview where you should take some programming questions and see if they know how to solve it or not. So that's, and once they did this presentation, we'll be looking on some specific stuff. It's this person did his PhD in a way that he was driving his research, or his advisor drove the research. So you can see somebody did a lot of work, and once you ask him a question that, oh, did you look at X and Y, why you did it this way, and they kind of don't know that much answer, he's much driven by his advisor, while some other people can, for example, our area is kind of broad a little bit, we do medical image processing, plus we want to implement this fast algorithm on computers, GPUs and so on. So we're going to see what kind of hands-on experience they have too. So that's how you're going to go and sell yourself to an industry, say show that you were more late in your research, you really know your area well, you weren't just doing what your advisor told you. we had a lot of this background and show how much hand experience you have and skills you have that fits within a company you are applying there, and or like try to choose a company that will make use of your skills the most.
Can I ask a follow-up question?
Yes, sure.
So I believe indeed many of the people in the room are PhD students, so I think this PhD issue is an important issue. Conrad mentioned that some of the projects in which PhD would work are highly classified. A number of people in this room, maybe the majority, are not US citizens. That includes myself, by the way. I'm not looking for a job, so it's so the question is there a room for foreign PhD graduates in industry? I believe in some of it is probably room, but maybe not that much.
So for us, we have much of our work is for the military, but then we have a space department that is about a quarter of the laboratories does space exploration. We've built 60 spacecraft, hundreds of instruments, Messenger, which is circling Mercury right now, New Horizons, which is heading to Pluto. Those are all our spacecraft. So we have let's see, we're the two that are going stereo going around the sun. There's two going around the sun looking at coronal mass ejections. So those types of research projects are open to non-US citizens. But in the majority of our classified work, unfortunately, we can only hire US citizens.
Really good. Off that too. Northrop does a lot of classified work as well. But a lot of times the classification of a project comes in from the full system level. You start pulling together all these little chunks and everything, you start pulling them together, enzyme mimics, they're all in class, you start putting them together in a big system, then you start getting the issues. So there's a lot of research that can still be done on the unclassed side of designing a new transistor. That transistor, you can go publish it, you can go, it might be a proprietary secret, but it's still open to US citizens. It's when that special transistor ends up in a chip, which ends up in this big module, which ends up on this plane, that performance now is classified. So there's still room for PhDs we have the whole advanced technologies lab where you guys are coming up with new designs for transistors, all this top of the line performance metrics. That in itself is open, but further down the line is where the issues come in.
But I suppose companies might prefer to hire somebody who may then be used to work on any of the projects. So it's not as valuable to hire.
I can add something to that. Even if it's restricted, if you're non-US citizen, which I am, you can still work on it as long as you can justify it. It depends on the degree of restriction. And the ITAR restricted, you specify this person as a foreign person, but and if the level of restriction is not high, and if you make your case, they generally let you use that person. And I think it depends on that person's background at work, and also background is in the country where they come from, probably. But it's not impossible.
What I was going to comment on is that, as I've gone through my 30-year career and watched a company like AT&T, which originally when I joined really had a lot of basic research, that over the years the company itself, again, it's all about money. The company itself hasn't been able to invest as much as it wanted to in basic research because it was all about delivering shareholder value and the rest. U.S. government, there's no doubt, the U.S. government provides money to support research activities. And a fair amount of U.S. government, you're going to get stuff that's associated with DoD, and then you're going to get restricted, if you're doing stuff, my organization does a lot of classified work, you're right, and so we have U.S. citizen requirement, we do a lot of work for the government. I can live vicariously through my son. My son right now is BME, and actually he's pursuing PhD in BME. And he just finished a work at National Institutes of Health and had a great opportunity at NIH. So there is, even there's money, there's research money from the federal government, it's not DoD research money. Maybe you guys know this, I'm sure, in terms of grants. So, I mean, if you're certainly in the medical field, I think you have certainly a lot. I think in some other fields, either you're going to have to find a private company that's got a big research budget. I think you're not going to find that many of them. or you're going to have to find some companies that, again, maybe get some federal dollars, and then you're going to have to probably stay away from the federal dollars that are DoD related. But there are federal dollars in other disciplines that you could, and I'm sure in medical right now, I think lots of money is available out there for the skills that I'm sure.
Yeah, but my own observation is I think there's a tremendous mismatch between sort of what conventional industry, which was the defense industry in our area, the people that they hire and the students that we have. 60 to 70% of the graduate students, PhD students in particular, are foreign nationals. In this department, and in almost every engineering department. And somehow this balance has not been achieved very well. I don't know what can be done about it, but there's a real mismatch. I think. It's too bad. We do see more and more young researchers moving into the health field. So engineering interaction with medicine is now growing stronger, more interesting. There are a handful of companies like Google, of course, which is hiring really smart, but there are only a few of them.
Highly competitive. They're highly competitive positions.
They're highly competitive. My own companies, we routinely hire foreign nationals. And we go through the immigration process with them, the 3 to 5 years that it takes. And it's been a great experience for us. They don't work on, we don't do classified work by and large, and they work on government sensitive. There are ITAR rules which are truly bizarre. We had a man, an immigrant from India who worked on an SBIR project. At the end of phase 1, the government required it to ITAR technology, but we got an export license for him. He basically exported his ideas to himself. I love it, I really. Yeah, so he continues to do it. So it's an interesting thing. Someday, we'll figure out a way to make the best and brightest across this immigration program. Let me ask just one more question, and then we'll have the audience. Do you find that graduate students that you hire have any misconceptions about the kinds of jobs that they do? Is there anything they can do to maybe get rid of those before they come to work? So they come in expecting maybe to have a kind of academic career like the one they were having as a graduate. And as you pointed out, Gerry, the job of your company is to make money. I own the stock. I'd be very disappointed if you did. So you find those conceptions students have, or you find them very adaptable?
To be honest, I've not had a problem. I mean, we're pretty specific in the job description of this type of work, but we do get mismatches, but as I mentioned, we're a fairly large organization, so people can move to find the work that suits their interests as well as their talents. There are 2 ways you can come into the organization. One is directly as a hire into a requisition for a specific job or specific task, much like was described in other cases. But then we have the rotational programs where you come into the rotational program, you have an opportunity to at least over 2 years see 4 different areas of work, and then can make some choices as to which of those best suits you too. So we rarely have a case where somebody had a misconception about what it was that they were supposed to do. Sometimes it's a mismatch in terms of talent or interest, but then again, movement's not a bad thing. And like you mentioned earlier that it's not out of the norm now for people to jump jobs. Even within organizations, but most of our organizations have enough flexibility that you can change jobs if you wish, even within the organization, I believe, just because you'd like to do something different. So I think all of that enables you to get that.
I think it's what I've seen in most of the hires that I've worked with is not so much of a misconception, but a very different change and transition from a culture of academia to a culture of working where you are now expected, every project could be a completely different team of people that you're working with different temperaments and different, we are a very diverse company. So you actually have to adjust and you need to have skills that you don't learn in class. Skills of how to work with all kinds of people. Skills that are very good communication skills and people skills that will ultimately be very helpful. Getting out of the idea that, oh, I have a master's degree and I do these courses and this is what I expect you to do. You could be doing anything. You could be just doing entry if that's what you're capable of. That's the first jobs you may have. So you have to be very adaptable, and it sometimes can be a shock. When I started working at AT&T, literally for a month I had no idea what I'm going to be doing because everyone would give me like small projects to do. They were just testing out to see, does he know how to do this? So it can be a shock because it's a very different environment. It's not like going to class and studying hard and taking an exam. That to me is a misconception of how they come in and everything that they've learned in school is what they can apply. You don't always apply.
Yeah, in case of I think we are trying to bring the hiring process to kind of clear that, right? And I think that's the point where you can learn about what company does and you can what you want. And if you had some misconceptions before the hiring process, after the hiring process, they should be gone. If it's not, if it still happens, then either we didn't do a good job during the hiring or you didn't really pay attention who you talk to and what they're telling you. So I think that's really the key point.
So I answer the second question first, now that's the first question. The way to get around it, the way to fix it is certainly avail yourself of internships. I mean, if you have the opportunity to get out there and work with companies that, you can come in and kind of test the waters with them, absolutely. I'm sure you've done that. If you're sitting here right now, you've already done that. But one of the maybe misconceptions, I think maybe a little more broadly, when you're in school, you get stuff done quickly. You go through master's, PhD, you're given X many years to get stuff done, and you achieve something. You achieve something in a very short period of time. And you think that that's the way the world works. And oftentimes, and I don't care whether it's AT&T, I suspect this is in other companies as well. Oftentimes when you got a great idea inside companies like ours, and you think, geez, I got a great idea, this thing speaks for itself. I'm going to be a hit, I'm going to be a success, and it's only going to take me 2-3 years, because of course that's the way the game's played. It doesn't take 2 to 3 years oftentimes. Oftentimes it might take 5-10 years to take your great idea and make it happen. Because there's lots of other things that are going on. Again, school's set up to get you out the door, to get your bright ideas out there, and then maybe you get the next step. Industries, again, right back to the money thing. Industries set up where you're going to have to deal with things you never dealt with before. These, I shouldn't even think lawyers. Lawyers, my gosh, what do lawyers have to do with it? You mentioned immigration law. I tell you, try and do things inside AT&T, you think you have the greatest idea on the planet. And then suddenly AT&T then has to bring that to the legal department. And then lawyers get involved, and then suddenly your great idea is going to be simulated maybe a year or two later after they have their say about it. And that could be about anything. That could be intellectual property, that could be telecommunications law, that could be anything. So one of the misconceptions might be that you think that your great ideas can see the light of day as quickly as they did in school. And generally you're going to hit a lot of negative inertia. And I think one of the things I would probably suggest, whatever field you go into right now, is get ready for that, be prepared for that. I'll say with AT&T, I'm speculating that this is similar in other companies. Some companies, the inertia might be less. In a large company, the inertia is probably going to be pretty high. Now, in a large company like AT&T, though, if you've got a great idea and you can get past the inertia, you can make it because you are in such a large company. So while a startup, maybe you can get there, and maybe you'll see the light of day and make a difference in some way. If you're a large company, you can pass that kind of stuff, you can make a tremendous difference. So I think that's, again, maybe one of the things just reinforces that don't be surprised when you walk into these companies that things don't move, at least in a large company, things don't move at the pace that you might be expecting. And you will work in the world we're in right now.
Yeah. Let's open it up to the audience for questions. We've got half an hour in this section for questions.
I have a question. So I guess this point was briefly touched upon by various people. I said the point I'm trying to make is that back in the 80s, most of the major breakthroughs, have happened partially in research labs funded by the industry, like Bell Labs, for example, and various other research labs that have made extremely huge impact, like in terms of basic research and everything. But over the years, we have seen this breaking down significantly, and have been briefly mentioned that the research opportunities available are not as vibrant as probably some 20, 30 years ago. So we have is there a reason why this is the case, and more importantly, what exactly are the opportunities available now, given that the PhDs have a very narrow skill set, and we have it's kind of hard to sell ourselves on a broad scale in that regard.
I think all of us are faced with budgetary issues. Affordability is something that has risen to such a level in everything that we do, and so for major corporations and even for research institutes like mine, the balance between what we can invest versus our cost to deliver is a very fine line. So a lot of that has driven these large research organizations we have down to be very small focused and product focused, because obviously for many of us it's about the product that we put out. So that has limited us in terms of basic research. Now as we talk about, there's still a lot of government grants out there for advanced research, advanced technology types of research. And those are the areas that we go after to maintain that S&T focus that sort of feeds everything that follows. One thing that, and you mentioned ITAR, which is it's just a double-edged sword, because I believe it's hurting our country more than it's helping our country, in the sense that it precludes us from teaming with others in ways that we could, around the world. Now, ITAR does not prevent academic pursuits. So again, for us, since we are part of the university, we have some flexibility there. But I'll tell you, it used to be that more than 75% of the patent applications came out of this country. That isn't the case anymore. It's coming from around the world. So organizations like mine, and I'm sure the multinational companies, are very focused on what's happening in research around the world, and we're all trying to figure out how to mine that and to make use of that, which means collaboration, and it means collaboration throughout the world, not just in our own country. So those are things that are challenges that are facing us, and I think that this nation is going to have to come to grips with that if we're going to continue to thrive, economically and in the product development that we do. So it's just a balancing of trying to put cost versus ability to invest is what's really driving down a lot of that front-end research, at least for us.
Yeah, maybe the other reason why some of these things happen, that in the past you've had certain individuals who had some good ideas and made some breakthroughs in AT&T, TI, other places, dated all the way back to Newton. But nowadays it's more like collaborative research, where it's harder to make new breakthroughs when you have 6 or 7 people who are completely agree on things. And in academia, I think in general, as a lot of attention, some of the research is what it does. You have a lot of people doing research that do not get on. So in all of that noise, in industry, you have to pick through that and find really what's useful and what to pursue. So there's some other reasons for that.
Other questions?
And so, reflecting back on your comment about impact, I think so, being a majority of PhD people, we're here to make an impact, like solve a different problem or come up with a new model so that people will cite us and essentially we will change some things in the world. So how do you think in a corporate environment people can make a PhD, let's say, makes an impact versus a startup environment compared to, let's say, academia or grad school?
I would say pursue your idea, right? If you're a PhD, you believe in something new that hits you one day, and you think it's a great idea, be stubborn and try to convince others that that's a really great idea. But also be reasonable, right? I mean, try to test it to see if it really works, right? But I mean, don't give up. Don't give up. And it will probably get people's ears, and if it's really great idea to be used at the patent and somebody said, I mean, it's really something that the industry will encourage. It will be really making a big impact if you are stubborn and believe it.
The other thing you have to do is you have to navigate the company. Is it, sometimes you'll end up in the wrong part of the company. Sometimes you might, you come in the door, because maybe that was the door that people had funding and everything to get you in. And then once you're in, then you got to find your way around, because to reinforce the point, you might have a bright idea, but you might have to align yourself with the right part of the company to really make a difference. I know that's the case inside AT&T. I mean, there's stuff that even my team's trying to do today, where if my team were located in another part of the company, we'd probably be more successful. There are parts of the company that AT&T still has where we focus on things that encourage more research stuff. We call it the foundry these days. And back in the days, it was AT&T Bell Labs. By the way, at least to go back to the first name, even when it was AT&T, it was Bell Labs, really, the government allowed that to be a monopoly. So quite honestly, the reason the money existed is because really somehow the government was holding the strings, allowing AT&T to invest research dollars. So really those dollars somehow in some way, shape, or form the government had some say. But I'd say is again, if you're saying, you draw the difference between startup versus corporate. When you get into the corporate environment, don't think that once you're in the door, you're in the right part of the company. Again, I don't want to speak for everyone here, but in large companies, you need to navigate. And the other thing this is obvious too. Malcolm Gladwell, I still have that in the tipping point. He talks about mavens, connectors, and salespeople. Good book if you ever read it. It's good book. When you get inside the company, find connectors. Find people who know the different parts of the company. In fact, once you find them, don't ever let them go. Because by the way, there are not as many of them as you might think. Oftentimes you're going to trip, you're going upon people and they know the person next to them. You got to find the person who doesn't just know the person next to them. You got to find the person who says, oh yeah, I know this person in here and there and elsewhere, and oh yeah, you need to know about this part of the company and that part of the company. If you got a bright idea, you want to make an impact, find yourself, seek out the people who seem to know, where all those places are, and then find yourself into the part of the company where you think you can make a difference.
At Northrop, we have what's called technology underground. It's very much aligning to the part of the company that you're interested in. It's open to anyone, and basically, if you have a great idea, you apply for funding, and oftentimes they'll give you a couple $1,000s to spend a couple weeks. You don't have to do your own job anymore. You can sit there and develop your own idea. And then at the end of it, have an open house, the corporate vice presidents show up, they kind of look at all these ideas. It really puts you in front of the senior management to see all these ideas, and they can sit there and start picking and choosing, like, this is a really good idea you have here. We're going to go pursue it further, and it could probably be applicable to this program that you had no idea even existed. It's applicable there, it'll save us money here, or it'll produce our performance, whatever it might be. Really puts you in front of the upper level management to do that.
Yeah, I think at AT&T we have something similar, which is the innovation pipeline. However, I think it's very important to be able to, like you were saying, align yourself with the right organization. But you also start becoming your own market. You market yourself, and you have to market your ideas. So not just your engineering background, it is how you market your ideas and how you can market yourself is very important. So that's something that you have to look for, but you have to align yourself with, look and see what your interests are and what group and organization does that. In a company like AT&T, it's so huge, I've never met Gerry before, for example. Work like 10 miles away. So you do need to know who are the people that you want to work with and find out what that group is and who does that kind of work.
I think one thing, there's a misconception out there that all good ideas, when they're put forward, either hit big or they don't. That's not true. It's really about persistence. So if you want to make impact and you believe in the research that you're doing, you have to just be persistent. and it may take years. I mean, I know researchers who kept working on something, believing in it, and 10 to 15 years later, it became a big thing. You see the ads on TV about all these startups that started up in garages and now are huge, billion-dollar companies. Or, the ads about the guy who says, what didn't you understand about, so many characters, and he's sitting on a yacht now. Okay, those are like the guys who play football and make it to the NFL. It's 1/10 of 1%. Same thing for ideas. So if you got an idea, if you believe in it, you've done the research, you see the vision for what that can become. It's just like he was saying, you have to become your own marketer. You've got to go look for it. It may not happen in a single company. You may have to look around and see, be your own entrepreneur. Figure out how to work with a startup or work within a company. Even within companies, you have to be an entrepreneur. You've got to figure out where to go get the funding for it. You may have to go get the research grant. Some of we all have seedling money, but then what sponsors or customer is really going to buy that thing and keep you going in the research? So it is about persistence. And if you want to make impact, it's about believing in what you're doing and just never giving up. And you may not succeed. I mean, it's a hit or miss game here. There's nothing fair about this. It's your idea, the idea that's needed to make a difference someplace and to make money.
The question comes to mind by looking at the panel. Is there room for women in the industry?
Sometimes we all are full.
We're old guys too. Yes, there is. The problem is there are not enough women coming out of your university. Okay? The hiring pool, look around the room. The hiring pool for women in high tech, our types of degrees is somewhere around 22 to 27%, depending on the degree. It's not enough.
And about approximately the percentage of women in the university as well.
Oh, it is. That's the pool we hire from. So, I mean, and then you throw in, for us, U.S. citizen on top of that, and it becomes really bad. So, diversity is a hard thing to achieve.
How do we change this?
So STEM programs that are most of our companies are involved in STEM programs, and we're investing a lot of money in the community to try to encourage the grade school, middle school, and high school kids to go into science, technology, computer, mathematics. It's so important to us. To the extent you can mentor somebody. I mean, there are a lot of kids in high school who drop out of engineering or science types of pursuits because of math. They just need somebody to mentor them through the math programs, and they'll take off. So, to the extent you can help us, we'd love to have it.
I think the problem is even more subtle than I thought. I used to like what you thought too. So I went to the Roosevelt High School Science and Tech Fair last week. It's the best science and tech students, 220 of them approximately. Somewhere between 60 and 70% of them were women. Girls, were young women. And this struck me, I was surprised. Science and tech, mostly young women. What's going on? And then I looked more narrowly at the sections. So they had work in biology, this, math, electrical engineering. There were 10 to 12 students, all women. And it was the same in the other disciplines: mechanical engineering, electrical engineering, and so on, almost all women. But in the other fields, things that were kind of like biomedical, mostly women. And a couple years ago, I went to a ball tournament in Northern Virginia where people build robots and compete and so on. And it was from middle school through high school. At the middle school level, it was a mix. The teams were about 50-50, girls and boys. By high school, it was much more boys, very few girls. Somewhere in there, we're losing. Engineering is losing. Science is not necessarily losing them, as the Roosevelt points out. It's engineering, it's us. And there's a contrast between our undergraduate population in electrical engineering, which is 9% women, and the graduate population, which is much more, is a much larger percent of women. Many of those women come from maybe China, Iran, India. We are doing fine in engineering outside our country. It's somehow very much a local problem, and I don't know what it is, but we lose them from the 8th graders doing bot calls and the seniors doing mail. Anyway, I comment on that. How about some more questions from the audience?
I'm trying to understand the role between like the real engineering position and the management position in industry, because some of the panelists are in management positions, and I want to know if I want to understand like how different it is for a management position. I mean, how much difference do you need to invest in yourself to get to a management position?
So I think what I would say is you are always managing something. So if you are working on a project, you are automatically managing the different phases of a project. If your career goals are not to have direct reports, you would still be managing at some level. It is very important to be able to understand management, because like I was saying, you have to work with a lot of diverse group of people. You have to understand how to manage the money, how to manage the time frames of the project. But yes, if you don't want to have a direct management role, there are a lot of people that I know that are very interested in hands-on engineering and have been doing that for a long time. The management aspect is really a career growth aspect that you want to look at, because you are now going to a more higher level management of projects than day-to-day looking at data and managing the engineering aspects at a very low level, grassroots level. So it's up to you where you want to go, but the higher you go, the more management you will have to do, because you are now going to be making decisions on projects. But I think every aspect of project you have to manage some aspects of it. So it's something that you will be required to learn.
If it's your aspiration, I actually would encourage folks like yourselves to actually pursue it. And the reason being is that, oddly enough, is that even within parts of AT&T that I work in, as people go through the management chain, the focus becomes less their technical background and more maybe their financial background and the rest. And then sometimes decisions are getting made and say, geez, you know what, that's really not the best decision to make from a technical perspective. I think a lot of folks like yourselves, yeah, I worked in industry, I kind of grew up in space. I think engineers in general kind of just say, geez, that's not for me. Please don't ask me to be a manager. Please, give me any other job, just not that one. But the reality is that I don't think enough folks embrace the role, because look, ultimately you're all going to have a boss. Okay, we all have bosses. Would you rather have a boss that talks your language, or a boss that just knows about the dollars and cents? You'd rather have a boss that talks your language. Well, you're only going to have a boss that talks your language, and maybe one day you decide to become one. And then so the next person will have somebody there that can support them. So what you have to do, though, certainly you got to figure out how to work well with people, and that's a given. But the other thing you got to get to know is you got to get to know, what does the company care about? It's not just, it's now you got to start embracing, why is that company in business? What's that company trying to do? Those are things other than your discipline and your research, and those are other things you got to acquire. But like I said, I wouldn't shy away from, again, to the extent that at one point in my career, oh, you're really going to ask me to do that? And I realized that, frankly, it was, to some degree, it actually helped the organization I was supporting, because I could engage in conversation with my team, but at the same time represent the interests of the company, and hopefully make a better connection between the two.
Yeah, one thing you have to be careful is don't try to go and become a manager just because you want to get paid more. Like in PI, because you may be up for surprise, there's certain aspects of management jobs you may not like, especially when it comes to managing people. When you manage technology, you're just doing interviews or whatever, math, whatever. When you deal with people, it can be pretty challenging. Anyway, but in TI, for example, we have technical and ladder, where we give opportunities to people who want to get to be this high or whatever, or not really be said, but really more opportunity to manage, as you said, some of the technology, right? So you will be managing things, either you're not a manager, you don't deal with people, but you'll be managing big projects, you'll be managing some research, right? And you don't have to be really strictly manager to do that, right? Foremost. In my case, for example, I'm kind of sitting on two chairs. I'm a manager, have a team, but I'm also on the technical level. So TI, you can do that, but it's even more challenging. You have to balance these two things. So you have to keep abreast of technology as well as dealing with people issues. So, but you have to make up your mind, why do you want to do something, right? And what exactly do you want to do? And then go from there.
I think there's a number of different tracks you can take. So, and depending on how the company or organization is set up, there is the individual contributor, which we've been talking a lot about. There is line management, which are supervisors of people who are doing the individual contributions. There are program managers who are really working with the customer, trying to find out what the customer needs are, bring the money in if it's research, then contract with the line organization to get the work done. And then there are technical leaders. And I can tell you that there's a screaming need out in any of our organizations for technical leaders. And those are people who don't necessarily manage people in the sense of their careers, but are managing the work, just within a program or project, who are, the chief engineer or lead engineers for that set of work. Tremendous need. Now we refer to it as the engineering T. And what you do is you start off as an individual contributor, and you build yourself your strengths in some pick whatever discipline you want. Really get deep into it, become very proficient in what you do, and then in your career you start broadening out. You start looking across different disciplines, and you start gaining experience across different disciplines that could either migrate you to a program job, it could migrate you, continue as an individual contributor or as a technical leader, or move into line supervision. You have all those choices to you. My example is I've got 36 years. It's 20 of them I spent in strictly technical work, where I was doing lead engineering types of work. At the end of that, chose to move over to program management because I wanted impact. I was seeing it was a case of having done all this work, I saw things that needed to be done, and I wanted to have impact. So I was willing to do less technical work so I could have that impact that I wanted to have. And then it goes on from there. So your journey isn't necessarily one of choice that you make coming out of school, like, I wanted to be a department head or anything. It is, I think, in my mind, find something that really excites you. Go do that for a while and be really good at it, and then look for opportunities within whatever the organization you are that will take you off on this different journey. If ultimately you want that impact, though, you're going to have to take on responsibility, whether it's the leading of the work or whether it's the leading of people. And it depends on how big a span of impact you want to have. What I do, I don't do myself, I do through others. That's what my life is about now, I'm doing it through others. And so that's what ultimately I think we migrate to, some of us. Others, you can stay very disciplined in a specific area and have great contributions there. It's just different.
You said it well. I have one question, and I suppose this is probably the last one during the time. So, previous, you have mentioned about navigating the company, and it's very important to be able to align yourself with the group that probably will be best for you. But again, I understand that it should be kind of challenging and intimidating perhaps for a new hire to be able to do that. And are there means and techniques in your various organizations for helping out people like leadership and trying to get them to know who to talk to if you have a particular question, who to approach if they have some new ideas that they want to take on and stuff like that?
We have a navigator program. And there the new hires office, someone who's been there maybe just a few years, so they're still new, still roughly the same age. So, and basically their job is to basically tell the new hire everything that they wish they would have been told when they first started. So from day one, it's things like how to fill out your time card, set up your email, how to set up your phone book. But then it moves into, here are the people you want to impress, here are the department heads, here, whatnot. And then it also, because they'll probably be in an entirely different part of the company as you, it gives you, kind of mentioned them along, here are the things to watch out for. Here are opportunities that I've had that you should take advantage of as well. And coming from someone who's been there a while, you kind of just take their word for it and mentor them along. And then eventually, when you've been there a couple of years, you'll get Brad paired up with a mentor who's been there even longer, an advisory engineer, chief engineer, the kind of work that is grooming you to improve your proficiency in your technical skills to navigate the whole company. Because the corporate world is entirely different from the academic world. And trust me, you will be lost if there isn't someone there holding your hand at the very beginning and telling you how things start working or not.
The thing that's the same though, and you mentioned it earlier, it's very important, it's connections. It's establishing connections. And many of our companies have new staff orientation programs, mentoring programs, early leadership programs. To the extent that you can take advantage of them, do. Go get those because you meet people. You meet people throughout the company, and those connections that you make early in your career, those people will migrate to different places in the company and other companies, and will establish your ability to have impact. It's because again, you can reach out and touch people and exchange ideas and collaborate on things. That's the power of an organization, like in any of our organizations. That's the power behind it. It's not about, again, you as an individual. You can bring so much to it, but you do it through working with others. And so I think those things are important. The one thing that I found, and it was taught to me here at Maryland when I was here as an undergraduate, I can't remember, one of my professors talked about finding mentors. And so there'll be mentoring programs, but ultimately in companies, you go there and you look at the people that you aspire to. I mean, you see people who have skills or capabilities or who just can do things that amaze you, and you aspire to be there. So go to them and say to them, you know, I'd like to form a mentoring relationship with you. And you don't have to do it through a formal program. I've done this through my whole career, and I've never been turned down. People, first thing they'll say to you is, well, why would you want me? You know, because it's like, but the reality is, if you can be specific with them, you can say, hey, I've seen you, I've seen what you do. I like the way you do it. I want to learn this. Tell them what you're looking for. Almost all the time, people will say yes. Sure, I'll do this with you. You know, and then you drive that relationship. You know, how often you get together, what do you talk about? But do that because there's mentors. And by the way, you always have supervisors. Mentors should be somebody outside your supervisory line because your supervisors have a conflict of interest, right? You get this work done. You know, you want somebody who doesn't have a conflict of interest, but who has a broader perspective on whatever organization you're in. Mind that. Go get their ideas. And that relationship will serve you well. Then it leads to what we call sponsorship. These are people who, for whatever reason, take an interest in you as an individual and want to pull your career along, you know, in some way. And so those mentoring relationships lead to sponsorships, which can be very powerful in your career development.
So I'll, if I'm splitting up the same topic. So the behavior I'd like to read that you should try to develop yourself. I mean, think about, I would gather that a lot of your thesis work or studies and the rest is such that you are integrating ideas from different domains. Oftentimes, and you could push knowledge in one field, but really what makes sometimes the most powerful new discoveries is when you take a piece of information over here and you integrate it with a piece of information over there, you fuse the two together, and suddenly you just say, wow. You see that in the technical work you're doing. The same thing works with people. You have to recognize that when you meet people in a company, you might say, why in the world do I care about that person? Like, I'm about to talk to a financial person. Like, why do I care about that financial? Why do I care about that? The reason you need to care is for the same reason that you're making those great, technical discoveries. You're fusing information. It's the same thing. You go into a company, care about those people that you don't think you really should ever care about. Care about them. Because somewhere along the way, you're going to find out that that was an asset, that was a person, that was a piece of information you needed to make a difference, to make, to bring something together. So you can have the mentors, and that's going to be there. You got to express an interest in all aspects of the company, because you don't know what you might trip over somewhere along the line. It's going to be that one piece of information that's going to allow you to make a difference. If the only thing you're going to focus on is the thing that you think you care about, you're going to miss all the other stuff. And it's the other stuff probably that's going to make the biggest difference. So just in terms of driving the behavior in yourself, don't become too focused and too narrow to just the things you care about. Try to keep yourself open and exposed to things that you thought you'd never care about. And you might actually find the gold nuggets there.
Yeah, I think like you were talking about making connections, keeping your eyes open is very important. In AT&T, I've been with AT&T for 19 years. Every few years, our organizations change. New organizations are created. New opportunities are created all the time. So if you're looking at what is being done, what is their vision, what the goal of their organization is, maybe it aligns better with what you're trying to do. And within AT&T, we encourage employees to get a chance at a new position first before we hire external folks. So it's very important to make connections, keep your eyes open, see what's coming. Telecom evolves so fast that what we are doing today, so we have something called Workforce 2020, which is really looking to see in the next 5 to 6 years, the skills and job requirements and what we'll be doing will be very different. So there are so many opportunities, there are lots of courses, lots of new areas that are being explored. So if you keep your eyes open and you have a good understanding of where you want to go, you can actually find good alignment.
Okay, I want to thank the panel for this first session, I guess. We'll be in another session at 12:30. Let's thank them now.